So this video looks at organic chemistry. Organic chemistry is the chemistry of carbon compounds, and these carbon compounds are called hydrocarbons because they're made up of hydrogens and carbons. Now, remember the carbon atom can make 4 bonds of 2 electrons each. So we learned that last chapter that carbon has 4 valence electrons and it can also make up to 4 bonds with something. So if we wanted to, each hydrogen can make 1 bond. So then you would form something like this. So carbon's got the 4 bonds around it. A few things before we move on that you need to know would be these terms here. So if somebody said, what is the full structure? Then you would draw it. Let's say we're looking at a 2 or a 3 carbon compound. The full structure would be showing all of the hydrogens, all of the carbons, and all of the bonds all stretched out. Okay, now the condensed structure is almost the same thing, but it involves showing the carbons and then the hydrogens grouped together and then a line. So you're kind of still showing carbons in the same general line in terms of how they're set up, but you're grouping all the hydrogens together. And then the molecular formula is what we learned about in chapter 5, where you have carbon, hydrogen, you have all of the atoms, and then a subscript to show how many of each atom you have. So for carbon, we have 3 carbons. For hydrogen, we have 3, 6, 8 hydrogens. And also, before we move on any further, we need to know that there are prefixes that you need to be aware of. So a prefix is something that goes before, okay, in the front of the word. So meth all the way to dec. So make sure you know these, have them written down somewhere. They're also on your periodic table, so you don't have to memorize them. But when you use them enough, you're just going to know what they are. So meth is like 1, carbon, eth is 2, and so on. Let's look at alkanes. Alkanes are hydrocarbons that are where the carbons are all single bonded. Okay, so you have something like, let me get the right pen here. So all the carbons are attached in single bonds. Okay, and then these would just be hydrogens coming off of there. So anytime you have that situation, you would have something called an alkane, and the prefix, you'd use the appropriate prefix to name this. So let's say we do have this. Let's say we have something like this. So if we wanted to name this alkane, what you do first is we are going to use a prefix to represent the number of carbons. So 1, 2, 3, 4, 5. So we have 5 carbons. So we're using the prefix pent. And because they are all single bonded, we would use the ending ane. And then we would just write down pentane. Okay, and that's how you would name a single bonded straight chain hydrocarbon. Now, so what I do want you to do is I want you to write down all of the alkanes from methane all the way to decane. And then I want you to do the following. So I want you to write down the name, and then I want you to sketch the backbone, and then write down its molecular formula. So I'll start off here. So meth represents 1 carbon, and then the molecular formula is C1H4. And then for F, we have 2 carbons, and then you top up with hydrogens. And the molecular formula would be C2H6. 2, 4, 6. Okay, so just do that for all of them. Propane, butane, pentane, hexane, heptane, octane, nonane, and then decane. And this is the general formula for an alkane. So you can pause the video and you can set those up. Now I want to move on to alkyl groups and branched hydrocarbons before we finish the lesson. So an alkyl group is simply a branch that's coming off of the main chain. So if this is my main chain right here, 1, 2, 3, 4 carbons, that would be the prefix BUT, single bonded, so it's a butane. Okay, but now I have this attached to group. So my main carbon chain is called my parent chain. So we need to make sure we understand that. The main carbon chain is the parent chain. So now we have to know how to name this attached group. And this attached group is coming off of carbon 1, 2, 3, 4. It's coming off of carbon 2. So we have to tell everyone that this is coming off of carbon 2. So what we're going to do is we're actually going to learn how to name these branches. So what you have to do when you're naming, first identify the parent chain, and we've already done that, it's butane. Then you have to number the carbon atoms in each backbone so branches have the lowest number. So if you take a look here, I numbered starting left to right. If somebody has started numbering right to left, 1, 2, 3, notice we'd get a 3. That's too big. So we want to go with this numbering system from left to right. So you always want to make sure that the branch has the lowest number. So we've done that. Then if there's more than one alkyl group, list them alphabetically and write the number before it. Include a dash between the number and group. So here it would be like that. Okay. And if the groups are repeated, write the carbon numbers separated by commas and a prefix di, tri, tetra to indicate how many identical groups. And I'll show you how to do that. So it would be something like 2, 3 dimethyl propane, for example. Okay, so this is the branch with a number of carbons. So methyl, ethyl, propyl, butyl, pentyl, hexyl, heptyl, octyl, nonyl, and decyl. And it goes from 1 to 10. So what we're going to do is take a look at how many carbons are in this branch. So there's only 1 carbon in the branch. So we're going to say our branch is going to be called methyl. So, and it's coming off of carbon 2. So it's 2 methyl, and then the parent chain was butane. And that's all. Now let's take a look at this one here. So we're assuming there's hydrogens all around. This is just more for practice. So let's say we want to name this compound here. You identify the parent chain. So that's 3 carbons, but you can also get a parent chain going in this direction. So you want the longest possible chain, and you have to understand that these straight chain alkanes can be rotated around. So they can be twisted and rotated around in like cells and in your body and everywhere. So they can, you sometimes have to kind of take some time to figure out what the longest chain is. So here we have a 1, 2, 3, 4 carbon parent chain, and we know it's butane. We have this branched group, and now we have to see what carbon it's coming off of. So we have to look at how we're going to number. So carbon 1, 2, 3, 4, or is it going to be carbon 1, 2, 3, 4? So I like that numbering system better. So I'm going to erase these numbers, and it's going to be 2. It's a 1 carbon chain, so I know that the branch is going to be called methyl. So it's 2 methyl butane again. Did I do this? Yeah. So notice here, this is exactly the same as this one, but this is all nice and linear, and this one is kind of rotated here. All right, let's look at this one here. 1, 2, 3, 4, 5 carbons going that way, or 1, 2, 3, 4, 5, 6 carbons going up. So this is my parent chain here. So let's name the parent chain 1, 2, 3, 4, 5, 6. So it's going to be hexane. And then I circle my branches. Now here, just be careful with the numbering. So I can go 1, 2, 3, 4, 5, and 6, or I can go 1, 2, 3, 4, 5, and 6. So here I get a combination of 5 and 3, so a total 8. And here I get a combination 2 and 4, so a total 6. So you always want to use the lowest combination when you're numbering, so I can get rid of those numbers. And they're all one carbon groups, and they're coming off of 2 different carbons. So one is coming off of carbon 2, one is coming off of carbon 4, and I have 2 of them, so I'm going to call it di and then methyl. The methyl is because it's a 1 carbon branch. And this di is because I have 2 branches of the same thing. Okay, so that's why I use the di. All right, let's look at the next one here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So here it doesn't matter if I use the linear or the one going up. It gives me the same number. 5 carbons would be pentane. And I have 2 branches, but they're different sizes. One is a methyl, one is an ethyl group because it's 2 carbons. And let's number 1, 2, 3, 4, and 5. And then if I did it this way, it would be 1, 2, 3, and 4. So 3 plus 4 would give me 7. So that's, this one is 2 and 3, so that gives me 5. So then I know this numbering is not right. And now I just go ahead and name. So this is a methyl group, and this is an ethyl. So I want to write it alphabetical. So it would be 3 ethyl, 2 methyl pentane. And when you have some time, I want you to sketch these molecules: 2-methylhexane, 3-ethyl 2,4-dimethyl nonane. Put a dash there. And when you're sketching, first you draw the backbone or you draw the parent chain. Then you number the carbon atoms, and then you fill in the alkyl groups. Okay, and that would be the branches. One last thing here before we finish up. Something called isomers. Structural isomers are compounds that have the same molecular formula, but a different arrangement of atoms in their structure. Okay, so if you look at butane, C4H10, 1, 2, 3, 4 carbons, and then you have hydrogens all the way around. That's butane, but you can also rearrange butane into this 2-methyl propane group as well, but these have the same molecular formula. So the molecular formula doesn't always tell you what the molecule looks like, because it can be used for various molecules. Okay, so there is butane or 2-methyl propane. So isomers do have different chemical and physical properties because of their arrangement. Last thing, alkanes are very unreactive because of their strong covalent carbon-carbon and carbon-hydrogen bonds, and long-chained alkanes are usually in solid form.